In this video, we will talk about how electrons are arranged in a shell. Electron arrangement, electron distribution, electronic structure, electronic configuration. All these terms all mean the same, how the electrons are arranged in shells. Group 8. This is the periodic table and this is group 8. Group 8 is sometimes called group 0. The elements in group 8 have a very stable arrangement of electrons, and their atoms all have 8 outer shell electrons except for helium, which has 2. This stable arrangement of electrons has a very important result. It makes the group 8 elements unreactive. Helium atom. It is the first element of the group 8. Here helium has atomic number equal 2 and mass number equal 4. We make distribution of electrons according to the atomic number, which is equal to, so we make distribution of 2 electrons. Here protons and here the electrons, we make distribution of 2 electrons. This is the nucleus and contains the proton and neutron, and electrons move around the nucleus, which is equal to. This is helium atom, the first element of group 8. Full outer shell of 2 electrons. Here, 2 electrons in the outer shell. Helium atom in the outer shell, we have only one shell which contains 2 electrons. We fill it with 2 electrons. Helium 2 atomic number, and we make distribution of electrons and written as 2. And it is stable, unreactive and stable because the outer shell contains 2 electrons. This stable arrangement of electrons has a very important result. It makes the group 8 elements unreactive. Neon atom. It is the second element of group 8 in the periodic table. Neon has atomic number equal to 10, equal to the number of electrons that has a negative charge that move around the nucleus. Here, neon atom, the first shell filled with 2 electrons, the second shell filled with 8 electrons according to the rule. Full outer shell of 8 electrons. Here neon, the first shell with 2 electrons, and the second shell, the outer shell, contain 8 electrons, which is called valency electrons. 10 as atomic number of neon and written as 2,8. And it is stable. This stable arrangement of electrons has a very important result. It makes the group 8 elements unreactive. Argon atom. The third element in group 8 in the periodic table is argon atom. Atomic number equal to 18. We make distribution of 18 electrons because atomic number equal to the number of electrons that has a negative charge that move around the nucleus. So we fill the first shell with 2 electrons and the second shell with 8 electrons and the third shell with 8 electrons. The outer shell of 8 electrons, here argon atom, the first shell 2 electrons, the second shell 8 electrons, and the third shell 8 electrons. When we add 2 plus 8 equal to 18. Argon 18 as atomic number, written as 2,8,8. It is stable, and this stable arrangement of electrons has a very important result. It makes the group 8 elements unreactive. Some questions. Number 1. One element has atoms with 13 electrons. Draw a diagram to show the electron distribution. We draw the first shell and then we fill it with 2 electrons according to the rule, and then we draw the second shell and filled it with 8 electrons, and we add 2 plus 8 equal 10, so the remaining from 13 equal 3. So we draw the outermost shell with 3 electrons. So when we need to draw the first shell, we fill it with 2 electrons, and the second shell filled with 8 electrons, and we see we count 2 plus 8 equal 10. From 13 the remaining is 3 electrons, so we fill it in the outer shell, and these electrons are called the valency electrons. In the first shell 2 electrons, in the second shell 8 electrons, and the remaining in the third shell, in the outer shell, which is called valency electrons. According to 13 electrons, we make distribution of 13 electrons. According to the rule, we fill the first shell with 2 electrons, the second shell with 8 electrons, and the remaining from 2 plus 8 equal 10, and we have 13. 13 from, we subtract it from 10 equal 3 electrons in the outer shell. Number B. Write the electron distribution in this form, 2 plus. Here, the first shell has 2 electrons, and the second shell has 8 electrons, and the third shell has 3 electrons. So we write 2 plus 8 plus 3, as these 2 electrons refers to the first shell, and 8 refers to the second shell, and 3 refers to the third shell, the outer shell. So 3 called the valency electron. This means that there are 3 electrons in the outer shell. The atomic number 13, aluminum, 2,8,3. 8, 2, 8, 3. C. Name the element. Aluminum. Aluminum, atomic number 13. Number 2. The electron distribution of boron is 2 plus 3. What is it for? Lithium. Lithium atomic number equals 3. So we make distribution of 3 electrons. The number of electrons that move around the nucleus equal to the atomic number. So we make distribution of 3 electrons. In the first shell, according to the rule, fill with 2 electrons. So the remaining is 1 electron. In the outer shell, we write it 2 plus 1, where 2 is the electron in the first shell and 1 the electrons in the outer shell, which is called, this 1 electron called valency electrons. What is it for magnesium? Magnesium has atomic number 12. This number, atomic number, equal to the number of electrons that has a negative charge that move around the nucleus. So we make distribution of 12 electrons. In the first shell filled with 2 electrons, the second shell filled with 8 electrons, and in the third shell filled with the remaining. We add 2 plus 8 equal 10, and the remaining from 12 equal 2. So we write 2 in the first shell plus 8 in the second shell plus 2 in the outer shell. These 2 electrons present in the outer shell, which is called valency electrons. 2 plus 8 equal 10 plus 2 equal 12 atomic number. What is it for hydrogen atom? Hydrogen atom atomic number equal 1. We make distribution of 1 electron because the atomic number equal to the number of electrons that move around the nucleus, which has a negative charge. So hydrogen atom filled with 1 electron only. So we write 1.